Good morning, students. Today we will continue our miscellaneous exercise. Today we will do questions from question number 11. Important questions we will do. Chapter 6, miscellaneous exercise. Important questions. Now, first question which we will do, that is question number 11. Now, open your NCERT book, read the statement and draw the figure. A window is in the form of rectangle surmounted by a semicircular opening. Okay, a rectangular like this. Surmounted by a semicircular like this. Okay, let the sides of rectangle are x and x, opposite sides, both are same. Let's take this is 2r because here it is required r and r radius of the semicircle. That's why I have taken here 2r. So these are the measurements. Now next, the total perimeter of the window is 10 meters. Total perimeter is given. Total perimeter of the window is given to you. Of the window, that is equal to 10 meters. That is 10 meters, and find the dimensions of the window to admit maximum light through the hole open. It means we have to maximize the area of this rectangle. So what is given? Perimeter. Perimeter means what? Perimeter means boundary of the window is the perimeter of the window. So it is 2r x semicircular plus x. It means it becomes, that is 2x, x plus x, 2x, boundary at the length of the boundary, that is 2x plus 2r plus semicircular. Semicircular means whole circumference is 2 pi r, and if whole circumference is 2 pi r, then half of it is, that is pi r. It means plus pi r is equal to 10. It means we have what? We have added all length of this boundary of this figure. It means 2x plus 2r plus pi r is equal to 10. Now simplify it. This becomes 2x plus, you can write it like this, 2 plus pi into r is equal to 10. Here you want the value of area. This is first equation, perimeter form. Now we have to find out area, combined area of two figures, semicircular and rectangular. Area is equal to length into breadth. Length is x into 2r. It is 2xr, length into breadth, and plus area of circle is pi r square, then half of pi r square, but it is semicircular. This is the area. Now, what is the value we can put here? So it becomes in one variable. Area is equal to, we can put here the value of, which is easier one to put, that is, we can put the value of 2x from here. We can put the value of 2x. What is 2x? 2x is equal to 10 minus 2 plus pi into r. We can put the value of 2x from first in area, that is r taking outside and it becomes 10 minus 2 plus pi into r is equal, sorry, plus half of pi r square. Now simplify it, this becomes 10 r minus 2 plus pi into r square plus half into pi r square. Now we have to differentiate it with respect to r. What is dA upon dr? That is 10 minus 2 plus pi into 2r. 2 right here and it is r. This is half as it is. This is 2 pi r. 2 cancelled by this. And you are getting, write down what you will get. dA upon dr. You will get that is equal to, that is 10 minus of 4 plus 2 pi minus pi into r. Or simplify it, comes out to 10 minus, this is equal to 4 plus pi into r. Put dA upon dr equal to 0. Get the critical points. What you will get? 10 is equal to 4 plus pi into r, and the value of r will be equal to 10 upon 4 plus pi. Now get the second derivative. Let's do the second derivative. dr square, it comes out 10 becomes 0, and this is minus 4 plus pi. This is a constant term. At r is equal to 10 upon 4 plus pi, it is always less than 0. What it means? It means A is, this implies A is maximum at r is equal to 10 upon 4 pi. If x is this one, what is r? So x is one side, second side will be what? And x, r is equal to this one. R is not, this is x or r. Okay. The value of x and now a value of 2r. Value of x, first we have to find out where we have to put to get the value of x. Let's see on the previous page. The value of x can be calculated when you put here x is equal to 10 minus 2 plus pi into r upon 2. From here you can get the value of x. That is, the value of x will be equal to, this implies the value of x will be equal to same 10 upon 4 plus pi, and dimensions of the rectangle will be, dimensions of the rectangle becomes, dimensions of rectangle becomes 10 upon 4 plus pi, that is x. Second dimension is 2r. It means 20 upon 4 plus pi meters. This is the answer of the question. Now come to the question number 12. Read the statement of the question number 12. A point on the hypotenuse of the triangle is at distance A and B from the sides of the triangle. Show that the minimum length of the hypotenuse is this one. Okay. First of all, draw the right angle triangle. Draw the right angle triangle. This is the right angle triangle. This is 90 degree. And a point is on hypotenuse. Let's this a point P. On hypotenuse, it is given to you. This is perpendicular from y axis from x axis. It is A, suppose it is B, and this angle is theta degree, and the name of the triangle is A, this is suppose B, and this is C. Hypotenuse H, we have to minimize the length. Minimize the length of AB. This is our target. Now, what is hypotenuse? Hypotenuse is AB, and that is equal to AP plus PB. Now we have to find out the value of AP and PB. AB and PB. So what is the value of AP and PB? How to get the value? We know the trigonometry. As we know, in a triangle, this one, first one, you can write AP upon small a is equal to cosecant theta, as sine theta is perpendicular to hypotenuse, and hypotenuse upon perpendicular, that is cosecant theta. And from here you can get the value of AP, that is A cosecant theta. Now in the second triangle here, I'm putting tick there, that is BP upon small b is equal to secant theta. As cos theta is base upon hypotenuse, secant will be hypotenuse upon base. That is BP is equal to b times of secant theta. Now hypotenuse AB can be written as small h. That is h is equal to A cosecant theta plus B secant theta. I have put the value of AP and PB in this first equation. So H becomes A cosecant theta plus B secant theta. Now differentiate it. DH upon D theta is equal to A into derivative of cosecant theta is minus cosecant theta into cot theta plus B taking outside, derivative of secant is secant theta into tangent theta. Put this equal to 0 to get the critical point. D theta equal to DH upon D theta is equal to 0. What you will get? This implies this is a minus sign. It means both can be equated. Cot theta is equal to B secant theta tangent theta. Convert into sine, 1 upon sine theta. This becomes cos theta upon sine theta. B into 1 upon cos theta. This is sine theta upon cos theta. What you will get? When you simplify it, it comes out equal to, this is, let's multiplying, cross multiplication take place, sine, 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 3 sines and 3 cos, and becomes A upon B. Let's write down. That comes out sine cube theta upon cos cube theta is equal to A upon B, or you can say tangent cube theta is equal to A upon B. Or what you can say, tangent theta is equal to cube root of A upon B. If tangent theta is this one, or you can say this is A to the power 1 by 3 and B to the power 1 by 3. What is tangent? Perpendicular upon base. It means perpendicular is given, base is given. What is hypotenuse? Hypotenuse will be equal to under the root A perpendicular square. Square means 2 by 3 power plus B to the power 2 by 3. This is perpendicular and this is base. So hypotenuse will be equal to this one. So sine theta will be equal to, you can write from here, sine theta will be equal to perpendicular upon hypotenuse. Hypotenuse is under the root a to the power 2 by 3 plus b to the power 2 by 3, and cos theta will be equal to base upon hypotenuse. Base is b to the power 1 by 3 and under the root hypotenuse is this. Now second derivative, we want these values, that's why we have calculated here. Now second derivative, d square h d theta square. What is the second derivative? First statement, a cosecant theta cot theta. It means we have to apply the product rule on it. What you are getting, that is minus a outside minus cosecant square theta cot theta minus cosecant cube theta, multiply them, and it is plus b times of secant square theta tangent theta, plus simplify it, it becomes q, like this. Now question, now simplify it, multiplying by minus sign inside, you will get a, take the common, a cosecant square theta taking outside, this is cot theta plus cosecant theta. Here you can take secant square theta outside, take the common, that is tangent theta plus secant theta, and you can see this is always positive. You can see from here the statement, for which value? For tangent theta is equal to a upon b whole power 1 by 3. What this implies? So length of the hypotenuse, the name is small h, is minimum when tangent theta is equal to a upon b whole power 1 by 3. Now we have to prove that h is equal to the given statement is, just put the values. Let's put the values now. H is equal to a into sine theta means, sorry, cosecant theta means you have to put reciprocal of the sine. We have calculated already sine theta, reciprocal the value of sine, you will get cosecant. That is a to the power 2 by 3 plus b to the power 2 by 3 upon a to the power 1 by 3 plus b times of reciprocal of cos, because b into secant 1, secant theta. This becomes a to the power 2 by 3 plus b to the power 2 by 3 upon b to the power 1 by 3. Where I put this value, a cosecant theta plus b secant theta. In this we have put the value of cosecant and secant. You will get this one. Now simplify it. When you simplify it, you will get the value that is equal to, simplify it, when you simplifying, you are getting the value whole power, taking this common first, a to the power 2 by 3 plus b to the power 2 by 3, you are getting a upon this one, b upon b to the power 1 by 3. When you simplify it, this becomes, this is power 1, this is power 1, 1 minus 1 by 3, that is 2 by 3. This is b to the power 2 by 3. This is power 1, this is power 1 by 2. What it means? It means you can add the statement because same basis power can be added. This comes out a to the power 2 by 3 plus b to the power 2 by 3 whole power, that will be 3 by 2, and hence proved. This is the question number 12. Now come to the question number. Now try 13, 14 yourself. Question number 15. Question number 15 is, read the statement. Question number 15. Show that the altitude of the right circular cone of maximum volume that can be inscribed in a sphere of radius small r is 4r upon 3. Show that the altitude of the right circular cone. It means altitude of the right circular cone is 4r upon 3. Let's draw the figure. Figure is, let's draw the figure. This is the sphere, and we have cone, right circular cone in this sphere. Let's draw the cone inside the sphere. This is the cone. Okay. Here we have to suppose the measurement of the cone and radius of the sphere. Okay. Let's, the radius of the cone is, write down, radius of cone is equal to, let's take it is x, and altitude means vertical height. This is a vertical height. Altitude of cone is, let it is y, and the radius of sphere, radius of sphere, what's going on, is r, small r. Okay. Now just write on a figure, that is C, naming, this is A, this is B, and we have taken radius is x, radius is x, then this is r. When I join this with the B, the center of this is r, and this already have written, this is r, and altitude, this means height, vertical height, that is y of, that is of cone, and from O to A, O to A means y minus r, that is OA. I can write here y minus r. Okay. Now from the figure we can see here in the triangle, in triangle OAB, in the triangle OAB, right angle triangle, this is a right angle triangle. So we can write, by applying the Pythagoras theorem, we can write it r square is equal to x square plus y minus r whole square. Simplify it, r square is equal to x square plus y square plus r square minus 2yr. You can say it is cancelled. What you are getting? X square plus y square is equal to 2yr. X square and x square is equal to 2yr minus y square. So we can get the value of x square from this derivation. Put this is first. Now question is, maximize the volume. Volume of the cone. Let's come to the next page. What is the volume of cone? Volume of cone is that it is V, that is equal to 1/3 of cylinder, volume of cylinder, 1/3 of pi r square h. Here r square is x, that's why it is x square, and h is y. So 1/3 of pi x square y. Now we have value of x square. So put the value of x square from the previous, which we have solved, 2ry minus y square into y. Now if you multiply it y 2r y square minus y cube. Now differentiate it with respect to y. dv upon dy is equal to 1/3 of pi, that is becomes 2r into 2y minus 3y square. This is 1/3 of pi. You can say 4ry minus 3y square. When you put dv upon dy equal to 0 for critical values, what you will get? You will get 4ry is equal to 3y square, or you can say this is 3y square is equal to, it means y, simplify it, 3y square, it means y is equal to 4r upon 3. This is the value of y. Now second derivative, d square v upon dy square. What you are getting? 1/3 of pi. First derivative, this becomes 4r minus 6y. At y is equal to 4r upon 3, what is the value of this? That is 1 upon 3 pi, 4 pi minus 6 into 4r upon 3. Simplify it. This will always negative, less than 0. So volume is maximum for altitude equal to, what is altitude? Y equal to 4r upon 3. This is the answer for the question number 15. Now we have to do now question number, let's do question number 17. Come to the question number 17. Question number 17. Read the statement. Show that height of the cylinder of the maximum volume that can be inscribed in a sphere of radius r, capital R, that is 2 times of capital R upon root 3, and also maximize the volume. Now in the previous question we have inscribed the cone in the sphere. Now here we have to inscribe the cylinder in the sphere. Okay, let's draw the figure first, then take the dimensions of that. This is a sphere. Take the cylinder inside this. Okay. This is a cylinder. Now we have to take the dimensions of cylinder as well as radius of the sphere. Radius of sphere is given, that is capital R. So we have to first x be the radius of the base. Let's take radius of the base, radius of base of cylinder, that is x. We have taken height y. Height of the cylinder is y. Then radius of sphere, that is equal to capital R. It is given in the question. Now draw this in the figure now. Height of the cylinder, this is y, vertical height, this one, that is y. And radius, when you plot this like this is the center of the sphere, and this is capital R, this is capital R, and this again is capital R. Now we have to take this radius is x. So from this figure we can say here is the right angle triangle, this one. This is the right angle triangle. From the triangle we can say this is y, height is y, this is A, B, C. Join this like this. So you can write from the triangle ABC, you can write it, that is R plus R is R square, 2R square. R plus R square means R plus R 2R, and 2R square is equal to base square and perpendicular square. It becomes x, this is x, so 2x square plus y square. It comes out 4r square is equal to 4x square plus y square. Now we have to maximize the volume of cylinder, that is pi r square h. R square is here x and h is y, so pi x square y. This is the volume of cylinder which we have to maximize. This is our target, to maximize the volume. So let here is volume is equal to pi x square y. Now we have to put the value of, I think easy to get the value of x square from here. What is the value of x square? 4 r square minus y square upon 4 is equal to x square. Put the value of x square here. So question will be converted into a one variable. This is x square means 4 r square minus y square upon 4. When you multiplied by y inside, then this becomes pi by 4 into 4r square y minus y cube. Now differentiate this statement, we differentiate with respect to y. What you will get? dv upon dy is equal to, that is pi upon 4 as it is. This becomes 4r square minus 3v square and put this derivative equal to 0. 4r square minus 3v square. Put this derivative equal to 0. What you will get? dv upon dy equal to 0. That is equal to, now 4 r square minus 3y square is equal to 0. This implies y will be equal to, as it is required, 2r upon root 3. You can, if you unable to solve, then I have to write down like this. This is y square upon 4r square upon 3. When you take square root, you will get this one. Okay, y is equal to 2r upon root 3. Now put the second derivative now, differentiate again with respect to y. You are getting d square v upon dy square is equal to, that comes out equal to minus 6 y pi upon 4. Now at y is equal to 2r upon root 3, this always be negative. What this implies? v is maximum at y is equal to 2r upon root 3. Now what is the maximum volume that we have to find out? Put the value of y is equal to 2r upon root 3 in the volume statement. What you will get? Let's put the value. You will get maximum volume. You have to show maximum volume will be equal to, sometimes it is written as v subscripted as like this. Maximum volume will be got pi by 4 into 4r square minus value of 4r square upon 3, 4r square into 2r upon root 3. Simplify it. This is 4 upon, this is LCM 3 root 3, and pi as it is. This is r square. This becomes r square into r. R square into r becomes r cube. So this is the answer. 4 upon 3 root 3 pi r cube. Now come to the question number. Now try one question you're on, that is question number 18. Do you're on now this question. And this is a completion of chapter. We have done exercise, miscellaneous exercise of chapter 6. Now do the questions. If you have any query, you have any doubt, then send on WhatsApp. We will solve that question also. Thank you. Have a nice day.